Wow. So joining me now, we have a new guest who's probably tired of hearing me prattle on, begging for money because he wants to talk science. We have Tom Gordon coming to us from Sydney. Is that correct?
Yeah, that's right. Yep.
So thank you. It must be early in the morning there at this point.
No. We've had time to have our coffee. We're all good. It's about 10 o'clock here.
Okay, so you are a business person late in the morning, and then astronomers. Well, I'm awake.
Yeah.
So Sydney is a fabulous city. Actually, one of your folks, Richard Saunders, is the reason I have this spoon. He's a magician who can bend spoons, and I couldn't figure out how he was doing it, so I stole one of his spoons, and I still don't know how he was doing it.
I'm
Anyway,
surprised he gave you one that was not bent.
he didn't really have a choice. I took it.
Oh, right. It's all in the mind or the wrist. I don't know which one of them. Probably one of them.
So welcome, Tom. Where are you coming to us from there in Sydney?
So I'm from the Sydney University, and I'm at the School of Physics, and my job is to talk to high school people, high school students about experiments that they have in their syllabus. We bring them into our lab. I'll just give you a quick tour of our lab here. This is our second-year lab where the second-year students do their experiments. Look at that. Beautiful.
That's an amazing space.
Isn't it cool? So this is where our second-year students do their experiments, and we bring high school students in here to do some experiments that they have in their syllabus. Sometimes they don't have access to them at their school. Sometimes the teachers don't know how to use them. The students don't know how to use them. They have them, but they're broke. All of that sort of stuff. We see about a quarter of all students that sit the physics exam in New South Wales, which is close to about 3,000 students every year. It's pretty cool.
That's kind of amazing, and you're leaving me kind of broken for a moment thinking about what an amazing opportunity that is for these students. First of all, that's one of the best physics lab setups I've seen.
I know, isn't it cool?
I've worked at Harvard, I've spent a lot of time at MIT. That's gorgeous.
There you go. I'll face that way. There you go. Lovely.
So we had a challenge earlier that I'm going to pitch to you that someone just actually posted the solution, and I'm going to see if you can get it because I didn't. Someone made a donation of $56.70 and said bonus points if you can figure out what physical constant this is, and I have to admit I had a moment of
Oh, that's the wavelength of 567. That'd be the wavelength of red light, I think. I might be a bit off there.
Red light's more getting towards the
yeah.
More thousands than that.
Yeah, right.
No, this is actually the Stefan Boltzmann constant.
Ah, of course.
that was kind of my, oh, dang it, how did I forget that? It has the crazy units of watts per meter squared, Kelvin to the 4th. So this this is one of my favorite do your unit checking students, because how many times do you raise temperature to the power of 4? And always remember, Kelvin is your friend.
Kelvin to the power of 4. You don't hear that often enough, do you?
No, you don't. But maybe we should. Maybe we should hear it more often, especially here in this International Year of Light. And temperature is what gets us at the color of light, after all.
Yes.
So I'm still just kind of speechless at how awesome your laboratory facility is. So how is it that you reach out to the students and open up the opportunity for them to step into your lab?
It came out of a few years ago. We had a change of syllabus here for the high school students, and it was such a big change that teachers threw their hands up and said, we don't know how to teach that, and they called out to us and they said, please help us. We don't have the equipment, we don't have the expertise, please, show us how to do it. So we ran a few workshops, and then the teachers after that were very impressed with the way that we did that, so we started inviting the students in as well. And that was about 14, 15 years ago. So it started from teachers not not knowing how to deal with the syllabus that they were given. And now it's going to change again, so we're going to have more challenges. But yeah, we've been doing this for about 14 years because the teachers asked for it.
So
and
we're going
it's a
to break
unique
away
program.
from this.
Yeah.
Sorry, I'm going to interrupt you for a moment because this is one of those crazy days where we actually had apple cider, at least I think that's how you pronounce this Twitter handle. In the last hour, we talked about how there was a potato salad recipe that raised $55,000 on Kickstarter, and it's now our arch nemesis because we're only trying to raise $36,000. And we told someone, hey, can any of you create a black hole sucking in potato salad? And they did it. And there's actually a meme version of this as well. It says, potato salad sucking black holes exist. Donate to CosmoQuest, and it has the donation link. And I just wanted to say thank you. That's awesome. But what you're doing is in a very different way, very awesome too. So you had this realization that there's teachers out there that have equipment, that have labs, they're trying to get their students engaged, and I mean, let's face it, it turns out that a lot of the teachers that are teaching physics, they don't have backgrounds in physics. They don't know how to use this lab equipment.
Exactly. So we see a lot of teachers that come through with their students who are taking notes on the stuff that we say. And the people delivering the content here are generally second, third year students at university. So they're not that far removed from high school students, yet the teachers are still taking notes because they don't have the expertise. We get a lot of, I mean, there are some fantastic science and physics teachers, but more often we see some PE teachers or sport teachers taking the physics class, or some schools just have one teacher, one teacher that does it all, or a single science teacher that has to teach 5 different classes from chemistry, environmental science to physics and everything else. Yeah, so they some of them get a lot out of it, and I'm trying to make it more relevant and beneficial for the teachers as well. Like, we focus on the students a lot, but I'm also trying to change the program we deliver so that teachers can get stuff out of it.
And this is something that we've talked about a lot throughout this Hangout-a-thon. We had Susan and Chuck Rule from Telescopes for Tanzania on earlier, and they were talking about how even there in Wisconsin, they were encountering teachers that had just never quite thought through the fact that the sun is a star. And it's,
yeah.
When you're the gym coach who perhaps has a degree in kinesiology, physics isn't exactly your forte, but sometimes that's what you find yourself teaching.
And we see a lot, even physics teachers or science teachers, they get a little bit afraid of the physics syllabus. There's no reason to. That's me though. I did physics. So some of them are quite intimidated by the physics syllabus. So we try and show them the stuff that we have, which is related to the stuff they have, and exactly how to use it, and exactly why we use it, etc. as well. Yeah, it's good fun. Like, my job is amazing. I get to sit in my office and write programs for students, and then all of a sudden I've got an idea, so I just come up here to the lab, tinker away with something, and make a new experiment. Good.
Now, I know some of the labs that we try and get into the schools include everything from your basic crashing a couple of carts together to rolling marbles down ramps to recreate Galileo's experiment. It's that basic, tangible, make loud noises, disrupt everything, and calculate what's going on kind of lab. This is what we do. What opportunities are you able to open up for your students?
So essentially, like, I've just lowered this so you can see. All these experiments here, all these benches have experiments on them, and we open up pretty much all of those to our high school students. The second year syllabus is not exactly, but there are definitely similar elements to what they study in second year and what they study in the final year of high school. So we get to use a lot of the experiments. So, for example, it's not going to make much difference, but over there, that's a setup where we look at the photoelectric effect. And
that's cool.
It's a second-year experiment, and we do it with our Year 12s. We've got over there, I won't take you there because of the light, but we've got a superconductor experiment. We've got a telescope. We've got J.J. Thomson and his experiment over there, a Hertz experiment. We do a lot of stuff in the syllabus, and we use the stuff in this lab for the high school students.
And for those of you out there listening,
they walk in here and their eyes just light up, and it looks like physics. Cool.
And for those of you out there listening who don't know these names that we're casually dropping, these experiments we're casually mentioning, the photoelectric effect is what actually got Einstein his Nobel Prize. People always think relativity, relativity, relativity. No, he actually got that original Nobel Prize for being the person who figured out that light comes in different individual energies, and it's that individual energy of the photon that can cause an electron to get ejected from an atom or not ejected from an atom. And that's Nobel Prize winning science. The J.J. Thomson experiment, I believe that one also led to a Nobel Prize. So you're giving your students the chance to do for themselves what in the past, well, earned scientists Nobel laureates.
And we don't let the students leave without knowing that either. They're aware that of all these people because it's in their syllabus, but the fact that they can get their hands on it and do the experiment that was done a couple of 100 years ago. There's actually another one. This is one of my favorites up there. You can see about there. There's a cosmic ray experiment, and it's very, very sensitive. So when some students are doing that experiment, the cosmic ray experiment, down there we have another experiment with lots of sparks. So if I time it right, these guys will be doing their experiment, I set off some sparks, and their data shows a neutron star very close.
That's a great way to mess with your students.
Yeah.
I just want to interrupt and say we are now at let me make sure it hasn't updated. We are now at $31,936. We're so close to $32,000. We're so close to our $36,000 goal. Just as a reminder, we have some amazing giveaways. I'm not going to go down the list. I will mention the awesomest one because we're within reach of if two people donate $2,000, I can pretty much say, I love you, and just talk science. If you donate $2,000, and I'm not expecting anyone to, but if you do, we have these amazing slices of palisite, a mineral that comes from a meteorite. This is a rock that fell out of the sky, got sliced and polished and made all pretty just for you, well, potentially just for you, and then was embedded protectively into a pyramid of lucite. This can be yours if you donate $2,000 to Astronomy Cast as a gift of thanks direct to you from Jeff Notkin. What did I say? I said Astronomy Cast. I meant CosmoQuest. Sorry. It's been a long day. Astronomy Cast is my other baby. It works as part of CosmoQuest, but you do want to be donating right now to CosmoQuest. So you're basically opening doors for people who don't otherwise have awesome opportunities to do science. Do you find that you're changing these kids' perspective on science as you give them the chance to do real research?
Yeah, a couple of great comments I've had is there was a young lady who came in here to do one of our physics workshops, and I heard her mumble under her breath during the workshop. She said, "Oh, I hate physics. I don't like this. This is rubbish. I'm bored. Let's go eat." Stuff like that. But at the end of the 2.5 hours that she was here, she walked up to me, and she was in about year 10, I think. So she was around 15 or 16, and you can imagine, just didn't want to be there. Walked up to me, arms crossed, and just basically spat the words at me. But the words were, "I didn't like physics before, but now I do. Thanks," and walked out. It was brilliant. I don't think it gets any better praise than that.
No, I just love the, well, buh, you made me like it. I hate you. That is such a teenager thing to do. It's glorious.
Yeah, that went straight into the brag file, that's for sure.
Now,
spelled with a double G, by the way, brag.
So, what do you find is the kids' favorite experiment that they get to do?
Meissner effect, without a shadow of a doubt.
I don't know that one. What's that?
So it's superconductivity. So we have a yttrium barium copper oxide superconductor here, and a couple of really strong magnets. You cool the ceramic, the superconductor, right down to about 77 Kelvin or 90 Kelvin or something like that, and then magnets will levitate on top of it. We have a couple of demonstrations of that. We have no idea how it works, but it looks cool.
Are these ceramic magnets, or are these
yes,
really?
they're ceramic magnets. Yep. So we have a ceramic superconductor and a ceramic rare earth magnet. Yeah, I forget, because I see this thing most days, right? But I forget that it's levitating, and it's pretty close to magic, because we don't know how it works. We'll get there one day, but at the moment we don't know. And when students see that, it's phones come out instantly. You get lots of comments, and yeah, it's pretty cool.
It's really amazing how much we still don't know about the things that we're able to do in a laboratory.
Yep.
Superconductors are just one of the many different things still waiting for understanding. How do you get your kids to understand there's still so much left to be discovered?
Well, with the Meissner effect, it's actually very, very difficult, because the syllabus will give an answer that's essentially a model for what's going on. And it's a model because we don't know the real answer. We really don't. I get asked all the time, so how does that work? And my answer is, I don't know. So the students will get tested on how it works, but it's a model. And with all models, there are inaccuracies, and there are misconceptions, and so it gets very difficult to explain to them how things work, because we don't know how it works.
So the way to think of this is kind of like back in the days where Kepler had finally figured out the equations to explain how planets orbit the sun.
Mm-hmm.
We got the whole elliptical thing going. We knew what the math, but we didn't yet know the why of the math. It took Newton to come along. We haven't had a Newton or an Einstein yet to explain superconductivity. Maybe part of why we're struggling so much to get it to happen at room temperature.
Yeah, sure. And I'll show you, this is our other favorite experiment. This is, I'm sure you can recognize that. That's just a Dobsonian telescope, yeah?
That's cool.
And it's got this thing on the end, which is, it's a funnel that I got from the hardware shop.
That's a sun filter.
Yeah, and on the front is some sheets from the back of an LCD screen, from a computer screen that didn't work. And when you click it in there, it's literally a projection screen for the sun. So we can take that outside, have a look at the sun, and you can see sunspots on it. You can see how fast the sun moves around. You can see all sorts of different things. The students absolutely love it, because it's one of those things. Again, I see it every day, but you forget that people don't see that every day. So they look in there, and then they look at the top of the telescope to see where the sticker is. They want to know where the sticker is. But it's not sticker. It's actually, and they say, oh, it's dirty. That's got lots of dots on it. No, they're sunspots, and they're about the size of 3 Earths put together.
I love the sun funnels. They're one of my favorite ways of sharing the sun, because especially in a telescope like that, you're not in danger of anyone looking directly at the sun, and it really gives you a chance to start to see the roiling edges of our sun, a star that is very active and doing amazing things that change from moment to moment and change from day to day.
Yep.
I do want to interrupt and say we are past $32,000. We're sitting at $32,056.42. We are so close, people. We have 2 hours and 34 minutes left. Am I doing that right? Yes, because the next hour is 8, 8 to 9, 9 to 10. We have 2 hours and 33 minutes left. We can get the $36,000, I think, I hope, maybe, please. Can we get there? I'm sure you have someone left that you haven't asked. Do you like your Wi-Fi connection? It was actually a group in Australia that figured out and now hold the patent for Wi-Fi. Just the fact that you buy Wi-Fi routers helps fund science, although there were some lawsuits involved in making that one happen that enabled Wi-Fi.
Yep.
If you like your Wi-Fi connection, you should donate to science. And hey, CosmoQuest, we're here. We want to teach you. We want to invite you to join us. And you know, if you don't have any money left to give, I get that. You may have heard me earlier saying that I'll support Telescopes for Tanzania by always doing their logo graphics. That's what I have that I can give. In my piece of paper. For a donation of $300 to $1,000, any of your donations that fall in that range, the one that is largest in that range, you will get a pair of Converse All-Stars in the size that fits the feet of your choice that are painted with amazing astronomy art. She is a truly beautiful artist, and I really hope that you will give and help her, well, share her art. She's the person who created Chuck the Squirrel that we share out with our Chuck Facts. So I keep interrupting you. I'm so sorry. I'm just so you keep bringing in kids, you keep bringing in teachers, we keep bringing in money. It's all good, I hope. What has been the most amazing thing that so far you've gotten to experience? That moment that makes it worth it to you that you're doing this.
In my job, because I've got a couple that happened before this job. And
go for it. Whichever one matters the most.
So one I did a course called Science Communication, and that was with a place called Questacon. I'm not sure if you've heard of Questacon. It's in Canberra, the National Science and Technology Centre. I did a science communication course there for a year, just over a decade ago, and that was one of the coolest years of my life. We got to travel all around Australia, talking science to as many kids as possible, thousands and thousands of kids. Brilliant experience. The other one I got to do, and this is a total brag, I don't get to talk about this one enough, is I went on the European Space Agency Student Parabolic Flight Campaign. That was when I was studying in France. Unbelievable. It's the Vomit Comet, basically. The European version of the Vomit Comet. Goes up and down in a parabola 36 times in a row. That's why they call it the Vomit Comet. So we got to do an experiment on that and experience about the same time, all up, of microgravity as Alan Shepard did when he was a Mercury astronaut. The best experience of my life, and all through science. Yeah, I was studying science. That was studying space science and stuff, and I was just lucky enough to get on the team to do that. Brilliant.
That is absolutely amazing.
Yeah. You don't forget that.
Go ahead. What was that?
No, that's fine.
I'm getting the message that our next guest is now in the green room, Amy Shira Titel. But before we invite her in, what one message would you want our audience to walk away with today? What one thing do you want to make sure they remember?
I'm going to steal a quote that was given just last night. Actually, we had an event last night at the Sydney Opera House where Stephen Hawking was beamed in to the Sydney Opera House in a 3D hologram. He's over in his office, and they beamed him in, and his last words were, "Be curious." So I'm going to go with that, spoken from the man.
That is awesome. Thank you so much for joining us. And where can people find you online if they want to learn more?
So we are at Kickstart Physics is what we're called. Basically, I'm the only one of those, so you can find me there. My Twitter is Gordoz, Gordeauz, like Bordeaux, the town, but with a G and a Z.
Thank you so much, Tom. It's been really great, and you're doing amazing things. And keep doing them, and keep changing kids' life by sciencing at them.
As are you, Pamela. Thank you so much.
Thank you. So just to sum things up, We are now, I love when I refresh the page and the numbers go up. We're at $32,176. We are $100 up from where we were last time I looked at this screen. We are inching ever slower